mind or emotion or reason an individual learns. And learning is essentially understanding formal proof evidence to inference. But in a realist framework, we understand that we never learn anything alone. If there was only one person in the whole universe, there will be no knowledge. Knowledge is possible only if there are multiple people. So it's a collective endeavor. And second, learning is critical understanding of human efforts in making sense of the world around. So this is a change. So within this realist framework, what are all the suggestions for going about in our primary level education when we are talking about Earth as a spherical object, is to draw from the history of our understanding of how Earth is a spherical object emerged, and also the debates that emerged when that idea came about. So if you look at let's say the history of that idea in India, okay, so you had arguments like the changing elevation of pole star when you go from south to north, or the curvature of the eclipse, curvature of the shadow of the Earth on the moon during lunar eclipse, or the ships disappearing hull first over the horizon. These were some of the evidences which are given in the debates about 1500 years ago. Okay, that these evidences, the claims is that if you assume Earth to be spherical, then these are easily explainable. Okay. Going further, Aryabhata even calculated the diameter of Earth using the fact that if I travel towards north a certain distance, my pole star elevates to a particular angle, and combining this one can compute what should be the circumference of Earth, from that the diameter of Earth. Okay. So one can see that there were multiple methods in investigating the shape of Earth, and almost all of them converge towards the idea that Earth is spherical. So this is what gives us a epistemic reliability, kind of truth-likeness of the claim that Earth is spherical-like. Okay. But a spherical Earth is counterintuitive. So to make sense of the counterintuitiveness, Aryabhata, for example, takes an analogy, analogistic reasoning, like Karamba flower. Okay, it's a floweret. Actually, we know that in that each flowers are at different direction, emerging from the center of the floweret to the outside. So using this analogy, Aryabhata argued that on the surface of Earth, people and things are living. Okay, creatures are living all across the Earth. Lalacharya, for example, used our everyday experience of seeing lizards hanging upside down on the roof, saying that like that Earth has attractive power, so that every part of Earth things can attach to itself. Then the argument was that anything that you throw up comes down. And it happens not only in your place, my place, every place. So it means that there should be something that is attracting everything towards the center of Earth. Okay. So these are the recent arguments that were given by a number of astronomers during that period to argue that Earth is spherical is understandable. Okay. It can make sense. Okay. But it's also very clear that the spherical Earth was also important in making sense of time is there, no? Making sense of day and night. Okay. So before let's say the spherical Earth and rotating spherical Earth giving idea of day and night, the Puranic cosmology, which was substantially prevalent in India. Is this for me? no, okay. Substantially prevalent in India, said that there is a Mount Meru at the center of flat Earth, and sun goes around the Mount Meru. For example, if this is the sun, I am the Mount Meru, the sun is here, this side of the Earth will be illuminated daytime, and because the Meru will cast shadow on this side, this will be night time. So the day and night occurs because of Mount Meru and sun going around Mount Meru. Okay. So how do you make sense of day and night? When the Earth is spherical, you can either assume that the sun is going around Earth or Earth is rotating on its own axis. Okay. So day and night explanation is also intrinsically connected to the shape of Earth when you want to argue. So in teaching, we should include that as a part of this as a single unit. And Aryabhata and others also said that birds and other things which fly from the surface of Earth are also carried along with the Earth, along with the air. Okay, so the air is also taken along with the Earth. So this also is carried along with the Earth. So that is why the birds can come back to their nest and all that. Okay, so these are the arguments. But there are also a different kind of questioning of these ideas. For example, Vedantin called Appaya Dikshita said that Earth cannot be rotating because there is a statement in Rig Veda which says that Bhumi Pratishta, meaning that Earth is fixed. So Appaya Dikshita said that Aryabhata should be wrong. So one can also discuss that objections raised from natural grounds and objections raised from dogma. So in science classes, we emphasize critical thinking. This is also one of the important aspects of critical thinking. How objection raised against spherical Earth from our experience is different from objection raised based on dogma. Okay. So the pedagogical strategy can include, like researchers have shown, physical model, digital simulation, body gestures, role play, spatial visual reasoning and so on. But using the way, for example, the idea emerged and was debated, and reliving that in classroom will give a critical understanding to students, not only about the idea of the spherical nature of Earth, but also how our knowledge is developed and continuously progresses further. That's it. Thank you. I think there is a question. Thank you. I thought somebody will ask this question, so I will have some extension time for my talk. It's okay. Just pulling leg. Okay, so in the group learning, for example, if I give certain pieces of evidence and certain arguments, and then make the group to think, what is your view on this? You debate. And then as a group, come and tell us what do you think. Okay? This is one way of making people reflect listen to others, counter argue, and then maybe make your opinion change or not change because you are not convinced it. Okay. This particular skill set, what is core of critical thinking, can be obtained if we make such kind of group discussion and then that being debated within the class. That's one. Second is role play. Suppose if I am Aryabhata and you are Apaya Dikshita, we are debating. So one of the student can be an onlooker. What is your take on this debate? Yeah. History and philosophy of science. I'm sorry. Sometimes some of us go into our niche area and use this kind of thing. It's history and philosophy.
Any other questions? Okay, if not, speaker for a nice talk.
Thank you.
Please go to the here and even the next slide. Yeah.
Okay, the next talk is by Durga. She is a student of Francis College studying physics and she volunteers a lot with astronomy. So we welcome Durga and let's begin.
Am I audible to everyone? Yeah, I have the mic on. Yeah. So, hello everyone, good afternoon. My name is Durga Sonawane and the work that I will be presenting today will be on the behalf of Astro Club of Ferguson College. So, today I will be talking about the initiative taken by Astro Club, that is School Astronomy Outreach. Why and how did we start this initiative and what were the learning outcomes out of it. So, this is a long-running initiative taken up by the Astro Club of Ferguson College. It is active for over a decade now, and every year we go to different schools to conduct these astronomy sessions. The core and fundamental idea behind this initiative was to ignite curiosity and make astronomy accessible to school students. So, there were a few clear aims that we were focused on. Firstly, to introduce astronomy and spark curiosity in schools, and to promote learning beyond classrooms, and lastly, to develop observation skills among the students, so that whenever they look up at the night sky and look up at a star, they know the name of it, or whenever we ask the name of a star, they know where it is located in. So, there might be a question as in, why did we choose astronomy as a subject for outreach? So, I am definitely sure about one thing, that in our lives, at least when we were kids, we have looked up at the night sky and been like, why are there so many stars, or why is this star so bright today? Why is there a moon, and etc. etc. So, basically, astronomy has always sparked curiosity among us, whether we be in India or anywhere across the globe. So, we feel that astronomy, the curiosity about the universe is universal, but the access to quality astronomy education is very limited, and that's what the gap that we saw and we wanted to fill in. We thought astronomy was a gateway to scientific thinking. So, when we conducted these sessions, we did not want them to be the regular boring lectures that were conducted in the schools. We wanted to make them fun, hands-on and observational. That's why we use sky charts, stellarium and other equipment such as models that we made for the Astro Club events. So we took these models to schools, we took telescopes there, and we also made some models in the classrooms. So this is a wave model. So it was made using straws and clear tape, which the students also made. So it was something that the students got to make, and they also learned a lot through it. So this model was used to demonstrate transverse waves. Similarly, longitudinal waves can be demonstrated using slingies, etc. We used everyday analogies so that the student can relate to the concepts that we taught. For example, how does a star's core heat up? So you can give an analogy like when matter comes together. For example, when you are alone in the lift, you don't feel as hot. But when the lift is jam-packed, you feel sweaty, you feel hot. That's how matter clumps up and star's core becomes hot. That's a very easy analogy to understand. So since this initiative was aimed towards being multi-tiered, we also targeted different types of schools. First one being private school, then second one being mediocre, and third one being low income or ZP schools. So talking about situation or our experience in private schools, so the students there had some prior exposure to astronomy as a subject, and the sessions we conducted there were mostly in English. The students saw astronomy as something, as a recreational subject or something, some enrichment beyond the curriculum that they had. One very interesting thing that happened was the teachers were actually encouraged to open astronomy clubs in schools after the session we took, since students showed a lot of interest in astronomy. Talking about mediocre schools, so here the students did not have as much prior knowledge about astronomy, and some even encountered it for the very first time. The sessions we conducted here were mostly in English and Marathi, and learning was based on mostly textbooks, and very little was, like they were not very encouraged to think beyond what was taught in their curriculum. Even as you can see in the image, even teachers were very enthusiastic about the sessions we took, and they sat in the sessions themselves and appreciated the efforts later. Talking about low-income schools, so the students here did not were of a very poor background, and mostly their parents were daily wage workers, etc. So they did not have any resources, and mostly they did not even have any access to astronomy as a subject. They did not had that much knowledge. So the sessions we conducted here mostly were in local languages such as Marathi, Urdu, Kannada. But a thing which was very interesting in such schools was that the students were extremely engaging and extremely active. Whenever the sessions were there, they had the most amount of questions and were always curious to learn more. So that was something very interesting about such schools. Also, sometimes we did not even have classrooms to conduct these sessions, so we conducted the sessions outside of this school, like on the ground, etc. So during this program, we observed a few things, and there were a few gaps that we felt need to be highlighted. Firstly, we felt that there was unequal access to quality science exposure. Since in private schools there are a lot of facilities, students know somewhat about astronomy, but whereas in schools where there are no resources, there is very less exposure. Secondly, under-resourced schools are often excluded from hands-on science programs. So this was something that like it was very majorly seen. Although the school, the private schools, although they had a lot of exposure, they also had some exposure to hands-on sessions which was conducted by the school itself. Whereas in under-resourced schools there was nothing like that, and the students learned only through textbooks, etc. And lastly, limited encouragement to think beyond textbooks. So this was something that is very common in India and is common across all the three types of schools. Students are not really encouraged to think beyond what is taught to them, and that is something that we thought we could change, and we did see some results. So I have talked about this earlier a lot, but I would like to dedicate a slide to it. So the students' response was amazing. They were highly enthusiastic about the sessions and very participating. They asked questions which were beyond the syllabus as well. So we as volunteers tried to be very open to them, and we tried to bridge the gap that was there between a teacher and the student. We tried to be the middle person, and that is why students were very open to us, and they asked us things which were beyond the curriculum. They increased confidence in discussing astronomy topics, so that was something that we achieved through this program. They gained early exposure to astronomy. So this was something this program is focused towards, this initiative is focused towards, and we are glad that the students actually gained a good exposure to astronomy. And astronomy is seen as interesting and not intimidating by the students. So talking about impact on Astro Club volunteers, the most rewarding thing that I would like to mention, which is not there in the slides, is that we got an immense sense of satisfaction, and it is something invaluable. But if I want to qualify things, I would say that we gained some skills, some of them being improved communication and presentation skills. We got experience in teamwork and coordination. We understood the challenges of science education in India. And lastly, we got a stronger sense of responsibility towards science outreach. In this image, you can see that we called these students to Ferguson College to attend the poster exhibition that Astro Club holds every year. And the students were really encouraged to, they were very actively participating. The topics that were covered in this exhibition ranged from star formation to dark matter to dark energy. And these students, being just first or second graders, they were so interested in all of these topics. So that gave us a sense of achievement that we did ignite some of their interests in these topics, and they might pursue it further. So this initiative or this program has been very rewarding to all of us, but something that Astro Club is extremely proud of, which we can call as key achievement, is that we assisted Astronomy Space and Environment Center and NEETI to organize the largest solar eclipse practical session on 17th of December 2019, which also contributed to the India Book of Records. So in this, more than 50,000 students participated across 161 schools. So Astro Club actually helped this organization to conduct this session and contribute to the India Book of Records. So these are some acknowledgements that we got from different schools, and these are the certificates that different schools gave us for the sessions that we conducted there. And lastly, I would like to end the talk with this quote. When students look up at the sky, they don't just see stars, they begin to ask questions, and science begins there. Thank you very much.
Hello.
Hello.
I have two questions, if
Yeah.
So are you planning to expand beyond that? What are the future plans for this? Or because I'm pretty sure you're gonna get graduate from this college. So what are the future plans for this astronomy?
So thank you for the question. I would like to answer the first one, and then second one ma'am can take the question. So talking about challenges, so in rural or mediocre schools, the first challenge is to ignite that curiosity among students, since they are not very well known to these subjects, and also they are not that curious. But in order to ignite that curiosity, you have to be very frank and very good with what you are explaining. So that was one of the challenges, but it was not really a challenge since the volunteers were very good at it. And also, since you can see over here, we did not even have sometimes had the classrooms to conduct these sessions. So having a classroom, or sometimes they did not even had projectors on which we can like explain things and show slides, etc. So that we had to manage from our side, or take sessions I say on the outside of the school. So that's what I can explain. And second ma'am can explain.
Yeah, like she has been doing this for the last 3 years, 2.5 years. She's been graduating this year. So what she was working was also for other peers and other students who are also studying in the same thing. Now, as far as the future is concerned, as she mentioned about the problems which we are facing, we have to manage those schools, especially the schools which were away from the college, because the schools which were around the college, we used to bring them to the college for the activities, or they go there. But the schools which were away from the college, we have to make some arrangements for bags, things, rickshaw, this and that. So that way we have to spend a lot of money initially. But now IIT has given us a center for IRA Center and IIT for Science and India Center for Astronomy Research. So we are getting funds from that. And since I personally have retired from this college and I'm involved with IFI, now I can give full time, time, because earlier I was head for the center analysis committee and manage all these things, so it was just very difficult for me. But now I have to personally be everywhere, and now I want to really plan out that I think in were you there for my lecture also? Yeah, so we were talking about the science education outreach, which we had already started. So now where we have actually adopted 30 Jilla Parishad schools. So now I want to take up that initiative to go to mostly Jilla Parishad schools, because according to our Jilla Parishad, most of the high-end schools which are high fee level schools, they have their infrastructure in place, so they don't really need much except for the club and so on. But the lower and the lower ones are the ones which have to be focused more on. So now we will be coming up with a proper plan, and also some vehicles and airports where we will be doing that. Because already IFI is also doing something here. So what we are doing, what we cannot do something for that, so we have to manage it and we are planning for that. Right now these are the annual activities they do it because their interest is going to do that. And not only that, nowadays we have something called as system education. All the students have to do some digital things, some extra credits and so on. So we are also trying to do some of these things, give the extra credits to students. Students who do these kind of things should be giving extra credits. This is how I feel. I think that will also help the students and the community.
Okay. Thank you. We have one more question. While you ask that, I will request the next speaker to come and set up.
Okay, wonderful experience. So, just one question that in your 2.5 years of engagement, what is the best question that you came across from the basics when you were writing?
So
What excited you? What made you stop and think?
there were a lot of questions, but something that really motivated me was everyone asking that when will you come next, when will the next session be. So that was something that motivated me to study more and to make sessions more engaging from next time. Yeah. So thank you everyone.
Hello. आवाज येतोय? Hello everyone. Can you hear me? Everyone? Yes. Thank you. So hi, I am Sonal Thurve, and before starting the presentation, I would like to know that is there anyone from this audience who never wondered about what is shining in the sky so bright when they were little kid? Is there anyone? Please raise your hands. No one, right? No one is there who never wondered about moon or twinkling stars. So every one of us, some or the other time in our childhood, have looked at the sky and always wondered about what those shiny things are when it gets dark, right? So using that only, we are designing wonder and transforming school astronomy through experiential engagement. So, to introduce myself in brief, I am Sonal Thurve, and I have worked in astronomy outreach and education for about 20 plus years now. And I have been dealing with public in general, not a specific age group. And along with me, of course, there is a team of expert astronomy outreach and educators. So, we at WOW Astronomy, we design unique things for schools which cater their needs. So, let us talk a bit about the learnings from the field. So, why astronomy in schools is, of course, as I mentioned, everyone is awed by the night sky. So, astronomy sparks curiosity and imagination. Then, it is also interdisciplinary. We know that when it comes to astronomy, there is a lot of science involved, a lot of maths involved, when you get deeper into it, right? So, it also connects with culture, because when we were kids, we have heard a lot of stories from our grandparents. They have heard a lot of stories from their grandparents. And so, the cultural stories come to us from generations before us, and they connect us with the starry skies and the patterns we see. So, while working with all these years with different schools in different states of India, we observed some gaps, and these gaps were very common. And most of the speakers, dignitaries who have spoken for me yesterday, they also have mentioned these gaps. So, this is not new. That emphasis is always given on the concepts learning, which leads to rote learning in kids. So, while I was working with Ayuka SciPop, we used to have summer camps. SciPop does it still. So, there is summer camp for school kids. So, we used to try out these pre-post and post test, pre-test and post-test with the kids in the summer camp. The summer camp used to be there for 5 days. And we used to start with some basic questions related to astronomy. Then we used to teach astronomy through some experiments. And after the sessions or the week is over, we used to gather similar tests and the answers from the answers for the same questions. And we learned that even through simple pedagogical methods like TVV we mentioned earlier, role plays, students get to learn the concepts clear. So, even with the simplest of the concepts like phases of moon, which are also not clear for teachers who are teaching them in schools, those concepts get clear through experiential learning. So, we focus on experiential learning more, but in the schools it does not happen. Then, since teachers are new to the subject, or not everyone who is science graduate gets to teach sciences in the school. So, I have worked with schools in almost in all Maharashtra as well as Bihar. and then of course the other states of the country. And we learned that since teachers are not confident, they might not have their basic academic education in sciences, they are not that confident in teaching the subject. So that is another hurdle. And as I mentioned earlier, astronomy is taught as information, and no guided inquiry or no inquiry approach is usually used. So at WOW Astronomy, what we do is, of course, with the help of experts, we have designed kits, astronomy kits, which actually are more than just models. Those are experiments kids can perform throughout year. They can observe things, and through the observations, they can learn the concepts. I will give you some examples later. So we focus on inquiry-based facilitation. You can see some of the pictures over here. This is a lab, WOW Astronomy lab at one school. Then we of course conduct, just like even Durva mentioned, that taking telescopes to schools as well as to teachers, to rural areas, is it can trigger the curiosity. These teachers are from Jharkhand and they had never seen a telescope, or some of them had got telescopes through some Jilla Parishad schemes, but they never knew how to use it, what it shows, how it works. They knew it all theoretically. So by looking at their faces, you can see how happy they are. By looking through a telescope, at a daytime we were showing them moon, which is again a misconception that moon only occurs in night time. You can only see the moon at night time, but teachers saw moon through telescope before sunset. Okay, so they were very happy. So we conduct curated workshops for teachers as well as students. Experiential engagement when we talk about, so this is what it looks like. When we talk about experiences, astronomy is one subject that is more of consisting of abstract things, abstract concepts, then the phenomena or events never occur on a regular basis. There is no eclipse every full moon or every new moon, right? So there are no meteor showers every week, every month, every night. So when we are talking about such events, around which also some misconceptions and misbeliefs are there, spread across worldwide. So we need something to model it, or what we can say, to experience how those things happen. So we have made some models, we have designed some experiments which kids can perform, and before going to kids, we teach them to teachers, because not everyone of us can reach maximum number of kids, but if we teach one teacher, the teacher reaches hundreds of kids in a day. So we focus basically on teacher trainings. As Raka ma'am also mentioned, the National Education Policy, it focuses a lot upon experiential learning, hands-on experiments. So all these pedagogical design principles are used when we design all the models. So here you can see it's a very simple experiment. We had nothing to show how Samrat Yantra works or how sundial works. This is a picture from I was working with some monks and nuns of Tibetan monastery and nunneries. So that time, all I had was a pen and mobile phone. Okay, mobile phone to show compass. So to make things, make astronomy accessible even through low-cost tools lying around you. Even if you do not have fancy telescopes or fancy models to explain things, how can we use daily life objects or objects lying around us to teach astronomy is what we focus on. And the major thing we take into consideration is guided inquiry. So questioning is always encouraged. So here are some pictures of from the field. So some stargazing session with kids. Because in geography books as well as in science textbooks, the teachers teach students about how constellations look like, and at night just go home and look at them. But it never happens at school. Not every school conducts skygazing session dedicated to teach them what is already mentioned in their textbook. So we conduct skygazing sessions where through stories. Of course, stories are liked by everyone, no matter what their age is. So starting from the kids to oldest members, they love stories. So through stories, we build on the principles of astronomy, and we teach them concepts. Here you can see some hands-on astronomy going on. The teachers are very excited to look at the stars and what they are looking at through telescope also. So here is one of my favorite photo because did anyone recognize him? He is a field hockey player, very famous field hockey player from Netherlands, Floris Bovelander. So he was also amazed to look through telescope. So it's not only for any rural school or anything. Astronomy is like we all know, it's global and everyone loves to look at the skies. So here are some more photos. So when this works, this is what it feels like. Sorry for the blurred picture because it was a screenshot taken by someone. So this one day I received a call from one of my classmates. So I had never spoken to him since I passed my 10th. And I received a call and he asked me, Sonal, I know that you teach astronomy and all. You are an astronomer, so would you like to talk to my students? So I was in the office and said, okay, it's a lunch break, so I have some time. And he immediately connected me with his students. There were 20 to 25 students on a video call, and this was sometime in August, early August. I talked with the kids, I talked about the universe, the Big Bang, solar system and everything in 1.5 hours. And I asked why this was so urgent. Then he told me that these kids are appearing for an interview tomorrow that is happening at Ayuka. And that interview was for the NASA and ISRO selection about which yesterday Samir was talking about, the Jilla Parishad project. And when the news came, the students asked the teacher to call me first and thank me because 5 of those 20 students got a chance to go to ISRO and NASA. And what they mentioned is because we talked to you the earlier day, our nervousness, which was already built that we are going to be interviewed by Ayuka scientists, it was at peak. But when we talked with you, we felt really good, we felt confident, we learned a lot, and thus it became a little easy for us to talk to the Ayuka scientists. And this was the confidence that made those kids speak confidently and give their interviews, pass them and visit NASA and ISRO. So this is not only about me, this is about each and every astronomer, astronomy communicator who is sitting over here. We are encouraging the younger generations. And this is something I am really I was very happy to hear about. Apart from that, we also try making astronomy inclusive. So I am personally working with schools for kids with visual impairment and trying to design some models of astronomy so that they also learn about the concept not in a traditional rote learning way but in experiential way. So here we were just trying a scale model of a solar system, and at the end of the session the achievement was the kids came to me and of course they mentioned their will to learn sciences further. and even pursue astronomy, and what are the ways. So I am still not sure what are the ways, but I hope there will be that these kids having visual impairment will also get to perform experiments in astronomy in future, and they will also get to build their careers in the field. Yeah, so this is just one picture at the lab, and thank you very much.